Hey guys, welcome back. Today let's solve the problem, symmetric tree. We are given the root of a binary tree and our task is to check if it is a mirror of itself. We can say from the example given that for a tree to be a mirror of itself, the left node of the tree must be equal to the right node of the tree. When we check for symmetry, the root node will always be symmetrical. However, the immediate left child must also be equal to the right child of the node for the tree to be symmetric. If we go down the same path, you can see down this child, the left node is 3, and down the other side of the tree, the right node is 3. The same is true for the left node. You can see its right child is 4, and the left node of the right child is 4. What happens if both the left and the right child are null? This means that the tree is symmetrical. Clearly you can see the left and the right child are null. The left and the right child in this tree are null. And so these two children, they are symmetrical. We can check for symmetry in a binary tree using a recursive approach for both the left and the right sides of the tree. Because of this, our algorithm will be running in a time complexity of O of n. And in terms of space complexity, our recursive function calls will be equal to the same height of this entire tree. With that said, let's code up the solution. The first base case that I usually check is whether the tree is not null. So if the root of the tree is null, we can simply return true, because as we discussed, a null value in a tree means that it is indeed symmetrical. We'll define a nested DFS function and it will take the left and the right subtrees. We'll be using this nested function to check if the tree is symmetrical. The first base case for this DFS function is what happens if both the left and the right subtrees are null. In that case, we have found a symmetric tree, so we can simply return true. However, if the left side is null and the right side is not null, or the opposite is true, then that must mean that this tree is not symmetrical. So we can have that check. So if not left or not right, we can simply return false, because this tree cannot be symmetrical. Finally, we can have our last base case, and that will be comparing the values in this entire tree. So if left.value is not equal to right.value, then we can simply return false, because this is not a symmetrical tree. Now done with the base cases, we will be doing this in a recursive manner. So we can return the DFS call. For the left subtree will pass its left value, the right subtree will pass its right value, and we would like to do the same with the children. So we will be passing the left.right value and the right.left value. The return for this will determine if this tree is symmetrical. Once we do that, we can just call DFS outside here, passing the root.left and the root.right. And we can make sure to return this as our solution. Now let's run the code and see if it works. And yes, as you can see, it works and it's pretty efficient. If you enjoyed this video, please like and subscribe for more content just like this, and I'll see you in the next one.